Good day, welcome to this presentation on data communications and networking tree. Today we will be covering three main topics: wireless LANs, single area OSPF, and multi-area OSPF. My name is Michelle Malangkot and I'm excited to share this information with you. Let's begin with an overview of our agenda. Here's a quick look at our agenda for today. We will start with an introduction to wireless LANs. After that, we will discuss single area OSPF and multi-area OSPF. Wireless LANs, or wireless local area network, allows devices to connect and communicate wirelessly within a local area. It uses radiated energy waves or radio waves to transmit data, unlike the Ethernet LAN that uses electrical signals flowing over a cable or light on optical cabling. The main components of wireless LAN are access points or APs and wireless clients such as laptops and smartphones. The standards that govern wireless LANs are part of the IEEE 802.11 family, commonly known as Wi-Fi. Let's take a look at wireless LAN technologies. Here are its classifications. Wireless personal area network that operates in the range of a few feet, much like how Bluetooth works. Wireless LAN or wireless local area network operates in the range of a few hundred feet. Wireless wide area network operates in the range of miles. Bluetooth, an IEEE 802.15 wireless personal area network standard, uses a device pairing process to communicate over distance up to 0.05 mile or 100 meters. Wi-Fi or wireless fidelity, an IEEE 802.11 wireless LAN standard, provides network access to home and corporate users, to include data, voice, and video traffic, to distances up to 0.18 mile or 300 meters. Worldwide interoperability for microwave access or WiMAX, an IEEE 802.16 wireless wide area network standard that provides wireless broadband access of up to 30 miles or 50 kilometers. Cellular broadband consists of various corporate, national, and international organizations using service providers' cellular access to provide mobile broadband network connectivity. Satellite broadband provides network access to remote sites through the use of a directional satellite dish. Here are different wireless LAN modes. In ad hoc mode, devices communicate directly with each other without the need for an access point. This is typically used for short-term, direct communication between few devices, much like how Bluetooth operates. In infrastructure mode, devices communicate through an access point, which in turn connects to the wired network and provides access to servers and the internet. This mode supports larger networks and enables devices to communicate more effectively by sending frames to the access point, which then forwards them to the destination device. The service set that is used for ad hoc is the independent basic service set. In infrastructure mode with one AP, it is basic service set. In infrastructure mode with more than one AP is extended service set. Here's an example of basic service set. It uses a single AP to create the wireless LAN. This is the extended service set. It uses more than one AP. In this case, it has two access points, often with overlapping cells to allow roaming in a larger area. Now explore the specific standards that have been developed to ensure these networks are efficient, secure, and interoperable. These standards, defined by IEEE 802.11 family, play a crucial role in the performance and reliability of wireless networks. Let's take a closer look at these wireless LAN standards. The original IEEE 802.11 standard was established in 1997, operating at a frequency of 2.4 GHz with a data rate of up to 2 Mbps. Looking ahead, 802.11be or Wi-Fi 7 is expected to be released in 2024. Wi-Fi 7 will operate across 2.4 GHz, 5 GHz, and 6 GHz frequencies, with data rates up to 30 Gbps, and it will feature 320 MHz channel and improve multi-user, multiple input, multiple output, further enhancing network performance and capacity. This table summarizes the key characteristics of each wireless LAN standard, including their operating frequencies, maximum data rate, and notable features. Understanding these standards helps us appreciate the evolution of wireless technology and its capabilities in different environments. The original standard is the 802.11 with the frequency that operates in a frequency 2.4 GHz. Max data rate is 2 Mbps. The next one is the 802.11a. Frequency is 5 GHz. Max data rate is 54 Mbps. The key feature of this one is it has higher speed and less interference. The 802.11b operates in 2.4 GHz, 11 Mbps max data rate, and its key feature is it has greater range. 802.11g 2.4 GHz max data rate of 54 Mbps. The key feature is it is backward compatible with 802.11b. 802.11n operates in 2.4 and 5 GHz, max data rate of 600 Mbps. Its key feature is it is dual band and has multiple input and multiple output. 802.11 AC standard operates in 5 GHz frequency. Its max data rate is 1.3 Gbps. Key feature is wider channels and more spatial streams. Next is 802.11ad 60 GHz 7 Gbps short range high speed. 802.11ax 2.4 and 5 GHz max data rate is 9.6 Gbps. High density efficiency. 802.11ay 60 GHz 176 Gbps. Its key feature is it has enhanced throughput. And lastly, the 802.11b or the Wi-Fi 7 that was mentioned earlier. Moving on from wireless LANs, let's talk about OSPF or Open Shortest Path first. OSPF is a linked state routing protocol used in IP networks to find the best path for data packets based on the shortest path first algorithm. It has hierarchical design, fast convergence, and supports variable length subnet masking, making it highly efficient for the large and complex networks. Here's an example of single area OSPF. Single area OSPF is the simplest form of OSPF, where all routers are in one area, typically area 0. This configuration is easier to manage and configure, making it ideal for small to medium-sized networks. All routers share the same link state database, simplifying the routing process. In a single area OSPF topology, all routers are part of a flat structure within a single area. Each router maintains an identical link state database. The primary advantages of single area OSPF include ease of configuration and management, as well as simplified troubleshooting. However, this setup can face scalability issues in larger networks, leading to increased overhead and potential slower convergence times. Here is an example of single area OSPF done in Cisco Packet Tracer. This one is the multi-area OSPF. As network grows, multi-area OSPF becomes necessary. In this configuration, the network is divided into multiple areas to reduce the size of the linked state database and improve scalability and manageability. Each area is connected to a backbone area, typically Area 0, ensuring efficient routing and reduced overhead. In a multi-area OSPF topology, the network is organized hierarchically. With multiple areas, each router maintains a separate linked state database for its respective area. The advantages of multi-area OSPF include improved scalability, reduced overhead, faster convergence, and enhanced network stability. However, this setup requires more complex configuration and management, along with careful planning of area boundaries to ensure optimal performance. And here's an example of multi-area OSPF done in Cisco Packet Tracer.